Hello and welcome to Mrs. Law's class. In this lesson, I'm going to show you something called the change of base property for logarithms. So let's say that you wanted to evaluate log 4 with a base of 7. So you can't evaluate this because on our calculator, we actually only have the log button, which is base 10. So what we can do is, I'm going to set up this expression so that it equals to x. So this would be log 4 with a base of 7 equal to x. And then what I'm going to do is to write this expression in exponential form. Okay, so this would be 7 to the power of x is equal to 4. So now what I want to do is isolate x. Now I can do this by logging both sides. It's kind of like if I square rooted both sides, or if I divided both sides by 3 or whatever. Okay, so in this case, I'm going to log both sides. Now we can use the power law to bring the exponent x to be the coefficient. So now I have x times log 7 equals log 4. And now to isolate x, I just divide by log 7. So x now equals log 4 divided by log 7. So if you notice, since x is equal to this expression here, but then at the beginning, I said that x was equal to this expression here. So therefore, these two expressions must be equal. So that means that log 4 with a base of 7 has to equal log 4 divided by log 7. Now I've chosen a base of 10, but we can actually choose any base we want, hence the change of base property. So I'm going to just write this. So we don't want to go through this step every single time, making it equal to x, and then logging both sides, and then dividing. So we now can just use the fact that log 4 base 7 is log 4 divided by log 7. So this property is called, sorry, it's a bit messy here, is called the change of base property. All right, so what it states is that log a with a base of c can be changed to log a divided by log c. Now change of base because I can use any base I want. We can use base 10, but we don't have to. So I'm going to actually put a little b here to say that it can be any base. Now important to note that a, b, and c all have to be greater than 0. And also recall that b cannot equal 1 because it's a base, and c can also not equal 1 because it's also the base. So if someone asks you to evaluate log, let's say log 12 with a base of 5, to type that into your calculator, you're going to go log 12 divided by log 5. And you just type that answer out on your calculator. There's no mode to change, and you'll get 1.54. So same thing here, you can go log 10 divided by log 7, and you type that out, and you get 1.18. All right, let's see another use of the change of base property. So let's say we have an expression that looks like this. It doesn't seem possible how to do this. Of course, we can use a calculator, but let's say that we don't have one. I can take my log 2 with a base log x, sorry, my log 2 with a base x, and change that to log 2 divided by log x times log 5 divided by log 2 equals 6. So I can cross off my log 2's because there's one in the numerator, one in the denominator. So now I have log 5 divided by log x equals 6. Now I'm going to use the change of base property back to rewrite this as log 5 with a base x equal to 6. All right, so now I'm just going to scroll over here because I've run out of space. I'm going to write this in exponential form to solve. So this is going to be x to the power 6 is equal to 5. And now I can take the 6th root of both sides, or I can also just write it like this, which is also the 6th root. So 5 to the power of 1/6. So now I have x is equal to 5 to the power of 1/6. And if you want to type this out in your calculator, you should get approximately 1.31. All right, the last example I want to show you is this example 4, where I have log 5 with a base 8, I have log 3 with the base 4, but then I want to find an expression with log 15 with a base of 2 in terms of x and y, which are my first two logs. Now this seems complicated because they're all different bases. So what I'm going to do is I'm going to use the change of base property to change them all, because you can see that 2, 4, and 8 can all be written with a base of 2. So first I'm going to take log 5 and divide it by log 8, and that equals x. So 8 I know can be written as 2 cubed. So I'm going to rewrite this as log 5. I'm going to take a little bit of a shortcut or a missing step and write 3 log 2, and that equals x. And now what I'm going to do is now rewrite that back into one single log. So this will be 1/3. Don't forget that it's not 3 because the 3 is actually in the denominator. So this is actually 1/3 here. Okay, so 1/3 log base 5 with a base of 2, and that equals x. And so log 5 base 2, and you'll see why I'm going to do this in a little bit. I'm going to multiply both sides by 3, so I get log 5 base 2 is 3x. Now the reason I'm doing this, actually I'll show you back over here. Let's go back to this because our goal is to try to find an expression for log 15. So log 15 with base 2 is actually equal to log 2, 5 times 3. So then we can now expand that to be log 2 or log 5 base 2 plus log 3 base 2. So now I can see that log 5 base 2 is actually 3x. So now I can actually substitute that into the first part of the expression. So now we need to do the same thing with log 3 base 2, which is over here. Now I can use the change of base property, but I'm actually going to show you another way just so that you're aware of different ways that we can find the same expression. So for this one here, what I'm going to do is I'm going to rewrite log 3 with a base 4 equals to y in exponential form. So I have 4 to the power of y equals 3. I'm going to rewrite my 4 as 2 squared. So now I have 2 to the power of 2y equals 3. And if I now rewrite this back into log form, I now have log base 2, 3 equals to 2y. So log 3 base 2 equals to 2y. So this way actually was a little bit quicker, but I did want to show you how you can use the change of base property to change the base 8 into a different base. All right, so now what I have is log 3 base 2 is equal to 2y. So I'm going to substitute that over here. So that means that log 15 base 2 is equal to 3x plus 2y. And that's a use of the change of base property.